There is a canyon in the American Southwest where the walls drop 800 feet straight down, sliced so cleanly that geologists have spent decades trying to explain it. They call it erosion. They call it the slow patience of water cutting through sandstone over millions of years. But if you stand at the rim and look at the face of that stone, you do not see the chaotic, irregular surface of something worn away by weather. You see flat plains. You see parallel lines running at consistent angles. You see the geometry of intention. And the unsettling part, the part no official report will say out loud, is that those marks look exactly like the marks on a mountain range 6,000 miles away, on the other side of the world, where no river ever ran, where no flood ever reached, where the only thing that should have shaped that stone was the slow grinding of tectonic pressure across geological time. Same angles, same spacing, same depth ratios, same tool. If you are new here, subscribe and hit the bell. What we cover on this channel does not get covered anywhere else, and you will not want to miss what is coming next. The official story of the Earth's surface is a story about time. Given enough time, water carves canyons. Given enough time, glaciers grind mountains into shape. Given enough time, wind smooths everything into curves and dunes. Time is the explanation for everything that seems too large or too precise to have been made by anything living. But there is a problem with using time as a universal answer, and the problem is this: time does not leave straight lines. Time does not leave parallel grooves at consistent 17-degree angles across a vertical face of granite. Time does not produce the same geometric signature on a sandstone canyon in Utah and a granite mountain formation in the Ural range of Russia. Time is patient, and it is powerful, but it is not precise. Precision requires a mind. Precision requires a tool. What researchers in the suppressed history community have been documenting for the last 2 decades is a pattern that spans continents and stone types and supposed geological eras. They are finding the same cutting signatures in places that have no business sharing a manufacturing profile. Canyon walls in the Colorado Plateau, mountain faces in the Altai, cliff formations in the Balkans, rock exposures in central Turkey, quarry sites in Egypt that official archaeology dates to the Old Kingdom period, and then sites in Peru and Bolivia that official archaeology says were made by cultures who had no contact with Egypt and no access to iron tools of any kind. And yet, the marks match. Not approximately, not in general outline. The angles match, the toolpath patterns match, the spacing of parallel lines matches, the depth to width ratios of individual cuts match. Whatever made these marks was not random. It was not patient erosion. It was a system operating across an enormous geographic range, using the same equipment everywhere it went. To understand why this matters, you have to understand what a tool mark actually tells you. When a blade cuts through stone, any blade, from a hand chisel to an industrial saw, it leaves a signature that is specific to that tool's geometry, that tool's speed, and that tool's angle of approach. Forensic geologists use this principle all the time to distinguish natural fractures from human intervention in archaeological sites. Natural fractures follow the crystal structure of the stone. They follow lines of weakness in the mineral matrix. They produce irregular, branching patterns that reflect the internal architecture of the rock itself. Manufactured cuts do not do this. Manufactured cuts override the internal architecture of the stone. They go where the tool goes, not where the stone wants to break. And the resulting surface has a different texture, a different geometry, and a different reflective quality than anything nature produces on its own. When you apply this analysis to the canyon walls and mountain faces that researchers have been flagging, the distinction becomes impossible to dismiss. The surfaces in question are not following the crystal structure of the underlying stone. They are cutting across it, through it, ignoring it entirely, the way a saw ignores the grain of wood when the blade is moving fast enough and with enough force. These are manufactured surfaces. The question that follows from that conclusion, the question that nobody with institutional funding is allowed to ask, is who manufactured them, and when, and with what. The Tartarian framework provides one answer to that question, and it is an answer that fits the physical evidence in ways that the standard geological timeline simply cannot accommodate. The civilization that researchers refer to as Tartaria, the global predecessor culture whose existence is documented in maps, in architectural remnants, in the suppressed historical records of the 18th and 19th centuries, and in the physical signatures left on the landscape itself, this civilization operated at a technological scale that modern archaeology does not have a category for. Not because the evidence for that scale is absent, because the evidence has been systematically recontextualized, relabeled and reassigned to natural processes whenever it appears in the geological record rather than in an officially recognized archaeological layer. The canyon systems of the American West are a perfect case study in this recontextualization. The dominant explanation for the formation of the Grand Canyon involves the Colorado River cutting downward through the Colorado Plateau over approximately 5 to 6 million years, with the specific steep-walled profile resulting from the erosion resistance of the Kaibab limestone layer at the rim. This explanation has been the consensus position since John Wesley Powell's expeditions in the 1860s and 1870s. But the explanation has always had problems that the consensus narrative handles by simply not discussing them in mainstream presentations. The first problem is the flatness of the canyon walls in certain sections. True river erosion does not produce vertical flat-faced walls. It produces slopes. It produces the characteristic V-shape of a water-cut valley, or at most, a modified V-shape where harder rock layers create temporary ledges before the softer material beneath erodes away and the whole face slumps toward the river. What it does not produce is hundreds of feet of perfectly vertical wall face with no slumping, no erosional retreat, and no talus accumulation at the base that would indicate material falling away from an eroding cliff. There are sections of the canyon system where the walls look like they were cut vertically and then left alone, with the material simply removed rather than crumbled and carried downstream. The second problem is the parallel lineation visible on certain exposed faces. These are not joint sets, the natural crack systems that form in rock as pressure is relieved during uplift. Joint sets are irregular. They cluster in families of roughly parallel lines, but the spacing is variable, and the lines themselves are not smooth. What appears on certain canyon wall exposures are series of marks that are smooth, consistently spaced, and angled in ways that joint formation does not produce. The simpler explanation that the geometry reflects the path of a cutting tool is not in the published literature, because publishing it would require institutional suicide. The connection to mountain formations becomes visible when you start looking at the Ural Mountains, specifically the central and southern Ural range, where certain cliff exposures have been documented by Russian researchers working outside the State Geological Survey system. The Urals are ancient remnants of a mountain system that formed during the assembly of the Pangaea supercontinent and has been eroding ever since. By the time of any human civilization, they had already been mountains for hundreds of millions of years. They should show the irregular, complex erosional profile of very old, very weathered rock. And in most places, they do. But in specific exposures that Russian independent researchers have been photographing and measuring since the early 2000s, there are faces that do not look old. They look cut. They show the same flat vertical planes, the same parallel lineation at consistent angles, the same override of the stone's natural fracture pattern that appears in the canyon systems of the American Southwest. The angular measurements that these researchers have published show a remarkable consistency. The dominant cut angle at the Ural exposure sites clusters around 17 degrees from vertical. The spacing between parallel marks ranges from approximately 3 to 5 centimeters. The depth of individual marks ranges from 2 to 8 millimeters. When the same measurements are applied to the canyon wall exposures in the American Southwest that show anomalous lineation, the numbers return within the same range. Not identical in every case, but within the tolerance range you would expect from a large-scale industrial operation where individual tool units might vary slightly while operating from the same basic design specification. This is what a shared tool signature looks like. This is how forensic analysts identify that two different crime scenes involve the same weapon. The signature is not always in the absolute values. It is in the ratios the proportions, the geometric relationships between the features, and those relationships across 6,000 miles of ocean and continent are saying the same thing. The quarry sites bring the picture into sharper focus. The standard narrative parcels the world's major quarry sites out among the acknowledged ancient civilizations. Egypt gets the granite quarries of Aswan, the Inca get Sacsayhuaman, and the quarry sites in the Cusco region of Peru. Each civilization gets its own quarries, its own technique, and its own explanatory framework, and the frameworks are kept carefully separate so that comparisons between them are discouraged at the institutional level. But the independent researchers who have done comparative analysis of these quarry signatures have found that the separation is artificial. The tool marks at Aswan and the tool marks in the Cusco quarry region are more similar to each other than either is to the documented tool marks of medieval European stone cutting the technology that supposedly succeeded both of pasts. Them. This is backwards. If Egyptian and Andean quarrying were independent developments that reached similar technical levels through parallel evolution, you would expect their signatures to differ the way English and Mandarin differ, related at a deep structural level, but divergent in all the specific details. What you would not expect is the specific convergence the measurement data shows. Same kerf widths, same striation patterns, same corner-cut geometry at the points where saw lines change direction. The most direct evidence connecting mountain formations to canyon systems comes from sites where both feature types appear in close proximity and where the anomalous cuts on the mountain faces are clearly not the result of quarrying for construction material because no construction material was ever removed. These are cuts that go into the rock and stop. Cuts that create flat faces on mountain slopes where no flat face has any natural reason to exist. Cuts that appear at elevations that would have required either an enormous labor force working under dangerous conditions for no apparent purpose, or a technology capable of cutting stone at altitude with precision that hand tools cannot achieve and that we do not possess today in the form of mobile, large-scale stone-cutting equipment capable of operating on mountain faces. What would a civilization need to produce these marks? Working backward from the physical evidence, the tool or system of tools would need to be capable of moving a cutting blade through granite and sandstone, two very different materials at a consistent depth and angle, across surfaces that are not horizontal, at scales ranging from individual cliff faces of a few hundred square meters to canyon wall exposures of hundreds of square kilometers. It would need to be operable at altitude, in locations remote from any obvious infrastructure, and it would need to leave behind a signature consistent enough across 6,000 miles that the marks on a Utah canyon wall and the marks on a Ural mountain face read as coming from the same system. No technology in the official historical record does this. Not Egyptian copper saws with abrasive slurry, which leave a distinctive curved striation pattern that does not match the marks at the anomalous sites. Not Inca stone dressing techniques, which involve abrading rather than cutting and produce a different surface texture entirely. Not any industrial technology in the modern record, because modern large-scale stone cutting is a fixed installation operation. Quarrying equipment does not go to mountainsides, and it does not operate at the scale suggested by the canyon wall evidence without leaving behind the infrastructure that powered it. The Tartarian explanation is that the tool was not an instrument in the conventional sense. The researchers who have worked most seriously with this evidence working in the tradition of the mudflood research community, extending the analytical framework that began with the demographic and architectural anomalies of the 19th century reset, propose that what we are seeing in these marks is the signature of a directed energy system. A system capable of cutting through stone the way a laser cutter moves through sheet metal, controllable in angle and depth, operable at range, leaving behind the flat planes and parallel lineations that neither hand tools nor water nor tectonic pressure can produce. This proposal sounds extreme only if you assume that the energy physics of the Tartarian civilization was constrained by the same limitations as our own. But the evidence from the architectural remnants that the mudflood research has documented the cathedrals and civic buildings that appear in mid-19th century photographs of cities that supposedly had no large-scale stone construction capability, The star-fort designs, whose earthwork geometries require survey precision that contemporary accounts cannot explain, the network of structures whose acoustic properties and orientational alignments suggest a unified design intention operating across a geographic range too large for any documented ancient state, all of this points to a civilization operating at a level of technical capability that our timeline does not include, because our timeline was written after the reset that removed that civilization from the recoverable record. The mountains were shaped, the canyons were cut. The same tool moved across this planet at a scale and with a precision that the Earth's geology still carries as a signature, waiting for someone to read it without the filter of a consensus framework that made its decisions about what was possible before it looked at what was there. What you see when you stand at the rim of a canyon and look at the walls is not the patience of water across geological time. It is the record of a technology that no institution will acknowledge, operated by a civilization that no textbook will name, doing work whose purpose we are only beginning to understand. The evidence is in the stone. The stone does not lie. The only question is whether you are willing to see what the tool marks are actually saying.